Hi students, how are you? I am here with a new video that is very helpful to all of you. That is what is meant by a tangent to a circle and a secant to a circle. After discussing these two topics, I will solve more problems on this. Then the concept will become very clear to all of you. This topic is very useful to all academic classes, particularly high school, and who have been preparing for different competitive examinations like SSC, Staff Selection Commission, Railway Recruitment Board, Bank, and more. So, shall we? In geometry, if you take two lines, there will be three situations. The first situation is they may intersect at a point, or they may not intersect at all, or they may coincide with each other. These are the three possibilities. The first one is if you take this as a line and this as second line, they are intersecting at a point. This is called point of intersection. This is one possibility, and they may coincide each other. Means they will have infinite number of common points between them. You cannot differentiate these two as they are coinciding each other. The third situation may be they may not touch at all, they may not have any common point between them. This is the situation of two lines. When you come a curve and a line, there will be three situations. The first one is the line may touch the curve at a point. Then you will call it as parabola, which you have been learnt in the chapter polynomials. And they may not be touching at all. When it touches the circle, what happens is the question. That is the main topic. As in the case of two lines, I am taking the case of a circle and a line. There will be three possibilities here also. The first one, if you observe, the circle and the line will not touch at all. That means they will not have any common points. This is the case 1. If you see the case 2, the line PQ, I am naming the line PQ is intersecting the circle at two different points called A and B. The distance of this A and B is called chord of the circle. I already discussed what is meant by a chord in the previous video. You may watch that video also for clear understanding of the chord. Now AB is chord and the line PQ is called secant of the circle. See, this PQ is secant. Next, coming to the third situation, the circle and the line PQ will touch each other at a point. That means there is only one common point between the line and the circle. That point is called point of contact. Now the line PQ, which is touching, not intersecting, which is touching the circle at a point, is called tangent to the circle. See, PQ here is tangent. Okay, but in the case of secant, the line is intersecting, not touching, at two different points. That's why that is called a secant. See, this is the definition of tangent and secant. Once again I will say a secant is a line which intersects the circle at two different points and forms a chord here like this AB, and tangent is a line which touches the circle at a point, and the common point here is called point of contact. These tangent will have different properties. Based on different properties, we will solve different types of problems. Now I will discuss the properties. The property 1 says that PQ here is a tangent and the point A is the point of contact. If you join the 2 points O, which is center of the circle, to the point of contact, you will call it as a radius. This radius OA is perpendicular to the tangent PQ. See, you may observe that this is 90 degrees and this is also 90 degrees. This is very important. Basing on this property, you will solve different types of problems like finding the radius of the circle or finding the length of the tangent. If you join this O and Q, you will have a right angle triangle called OAQ. In this OAQ, angle A is equals to 90 degrees, then it will become a right angle triangle. By applying Pythagoras theorem, you can find whatever the data you want. Here you have one side and this is the other side, this is the other side. In these 3 sides, if you have data of 2 sides, you can find the third one. Second property says that for every point on the circle, if you take whatever the point on the circle, you can draw only one tangent through that point. You cannot draw more than one tangent. If you take like this is a circle and this is O and this is an external point. See, if you take a point here, you can draw this only tangent passing through this common point. And if you see the second point, from an external point, if you take any external point, let it be A, you can draw only 2 tangents onto the circle. You cannot draw more than 2 tangents. See, you can draw a tangent like this, you can draw a tangent like this. These 2 will become the 2 only tangents. You cannot draw more than the 2 tangents. If you see the property number 3, if you have drawn 2 tangents onto a circle from an external point, then the lengths of those tangents are always equal. See, I am taking a circle here. This is a circlet and this is center O. Now from the point A, which is an external point, see, you have to keep in your mind that you cannot draw any tangent through the point which is inside the circle. You can draw the tangent only through a point which is outside, exterior point. See, I will draw a tangent, one tangent. This is second tangent. Let it be C and D. Let it be P. By taking a point P which is outside the circle, I have drawn 2 tangents called PD and PC. Now if you join this point of contact and O, that will become a radius, and this is also a radius. What I am going to say is the lengths of tangents which are drawn from an external point onto a circle are equal. From this figure, length between D and P means the distance from here to here is equals to the distance from here to here, nothing but length of 2 tangents. So dP is equals to Cp. Here also there is various data through which you can solve different types of problems. If you join O and P, that will become the distance between the center of the circle and the external point P. Here this is length of the first tangent, this is also length of the second tangents, what I said, which are equal. This is the radius, this is also radius. If you observe, there are two triangles, ODP and OCP. In these two triangles you have 90 degrees here, here also 90 degrees, means two right angle triangles. By RHS axiom, which says that in any two triangles, if there is a right angle which is equal and hypotenuse, okay, side. See, right angle is there in these two triangles, and also hypotenuse is equal. Hypotenuse is nothing but common to these two tangents, and one side, this is one side. By this property, these two triangles will become congruent. On congruency also I made a video, please watch that video also for your better understanding of this concept. So by using this property also, you may find the distance between the point O and P, and also you can find radius of the circle, otherwise you can find the length of the tangent. Property number 4, this is also very important. See, if you take two concentric circles are circles which are having common center. See, this center O is common to both the smaller circle and bigger circle. By taking two concentric circles, and if you draw a chord for the bigger triangle, see, for bigger circle, in such a way that it is touching the smaller circle, then the point of this touching will divide the chord into two equal halves. See, let it be the point of contact of smaller circle and the chord. Then what I am going to say is, this point O will bisect the chord into two equal halves. That means the length between A and C is equals to length between C and B. By using this data also, you can frame different types of problems and you can solve, you can find the length of this chord or length of the radius and length of this bigger circle also you can extract by using the given data. Property number 5. Property number 5 is relating to angle. I have taken an external point P and I have drawn two tangents AP and PB. You know that lengths of these two tangents are equal. Now there will be an angle formed between these two tangents, that is angle APB. This angle is equal to, see, if you join this O and A, this is one radius, this is also a radius, which are both equal, and if you join this A and B, which forms a chord, then there will be two angles, one is here and the other is here. This angle APB, which is between the two tangents at the external point, is equal to sum of these two angles, and these two angles are also equal. Therefore 2 into, you may write OAB or 2 into OBA. Since these two are equal, you may write 2 into this angle or 2 into this angle. This is also important property by using which you can find either of the angles, this or this. Property number 6. Property number 6 says that if a circle is drawn inside a quadrilateral, whatever the type of quadrilateral, that is not a matter, if this circle touches all the sides of the quadrilateral, then sum of lengths of opposite sides is equal. That means if you take AB, its opposite side will become CD. AB plus CD is equals to, if you take DA or AD, DA plus BC, these lengths, sum of lengths of opposite sides are equal. See, these are secant, tangent and their properties. By using secant, you are having different properties like major segment, minor segment. Basing on those also, I have made a video. You may watch that video also, and in later videos I will solve different types of problems basing on all these properties. I hope this video is helpful to all of you. So far, if you didn't subscribe to my channel, kindly subscribe to my channel to do more videos. You will meet in problem solving session on these properties. Until then, have a nice day. Thank you very much.